Okay, so we've done two examples so far that covered our first two principles for how we build our particular solution, the way that we choose the functions that belong inside of it. First one was using terms that appear in G. Our second one was using derivatives of terms that appear in G. And our last one is a little bit more complicated. So what it's going to be is if any of the, I'm going to call them G sub I of X, so any G1, G2, so on and so forth that we picked from A and B, it's A or B actually. So if you went through those steps and you built all of the G's that you thought that mattered, but if you found out that any of them were already included in the fundamental solution set for the homogeneous equation, so if any of those G's that you found for this G of X right here, the non-homogeneous part, were also found for the homogeneous part, the constant coefficients equal to 0. That's the case we're talking about here. And if that happens, then our approach is going to be to multiply by powers of X until you arrive at a new solution. So kind of the same way when we had repeated roots in last section, we would multiply by powers of X until we had enough solutions, y1, y2, so on and so forth. Now we're going to multiply by powers of X until we have enough G1, G2, so on and so forth to fill up our particular solution. So for example, if we had G equal to e to the 4x and y1 equal to e to the 4x, y2 equal to e to the 2x, then what we would say is that G1, using our first rule, would be e to the 4x, but e to the 4x was already in our fundamental solution set, so I would say, okay, I better multiply by a power of x. We're going to see that in the next example that we do. So let's see. There we go. So in this example, we're going to do y double prime minus 5y prime plus 4y equal to 8e to the x. And we're going to note that if you sat down and tried to solve y double prime minus 5y prime plus 4y equal to 0, you would find that y1 was e to the x and y2 was e to the 4x. That's something that you learned how to do last section. In this section, what we would say is our g of x, the thing on the right-hand side of the equation, is 8 e to the x. And your next step is to try and solve for what y sub p is. And so using kind of our principle A, we would say, okay, it's probably a times e to the x. And then using principle B, we would say e to the x has derivative e to the x, so everything's okay. But then using the last principle we just covered, C, e to the x is already y sub 1. So I have to add on an x in order to actually have a new solution. So I'm going to, instead of having that arrow, just say that step A was looks like e to the x. Step B was, I've already covered the derivatives. And step C is, that solution already exists. I'd better add on a power of x. And so this is my y sub p that I'm going to go ahead and plug into my differential equation to see what happens. That means I have to go ahead and take derivatives. so that I can fill up the whole differential equation. So yp prime is going to be a times the derivative of x is 1 times e to the x plus x times the derivative of e to the x is just e to the x. So that's a times 1 plus x times e to the x. That might be a convenient way to have it written later. And then the second derivative is going to be a stays the same. The derivative of 1 plus x with respect to x is still 1. So I get e to the x plus 1 plus x times the derivative of e to the x is e to the x. So this is just going to give me a times 2 plus x times e to the x. If this kind of went too fast for you, take a second, make sure you feel good with the derivatives. All I did was the product rule twice. And you might want to have like a derivative calculator handy when you're working on these problems. The next step is I assumed yp looked like this. I found all its derivatives. Now I can plug it into the differential equation. So what I should have is yp double prime minus 5yp prime plus 4yp equal to 8e to the x. And I just calculated all those derivatives. So it's going to be a times 2 plus x e to the x minus 5 times a times 1 plus, 5 times a times 1 plus x e to the x plus 4 times ax e to the x, all equal to 8 e to the x. And next up, what I'm going to do is try to simplify everything into an algebraic equation that I can solve. And something that's going to make that a lot easier for me is to note that e to the x is hanging out everywhere. So I can go ahead and cancel that out right off the bat. So I've got a times 2 plus x minus 5a times 1 plus x plus 4ax is all equal to 8. Yeah. If you didn't do that, it would be fine. It would just be kind of messier to look at. Actually, yeah. Maybe I should just hold on to the e to the x. I'm not really sure. I think that this is more pleasant to look at, so I'm going to do it this way. But if you want to, in your own work, go ahead and hold on to the e to the x, it's fine. It'll just stay there the whole time. Plus 4ax equal to 8. All right. And this is the part where I group like terms. So it's going to be, I see x's. So there's going to be some stuff attached to x's. Let's go ahead and do that real quick. So I've got x times a, x times minus 5a, and x times 4a. So I've got a minus 5a plus 4a times x. And I've got ones. So that's going to give me, let's see, my underlines are going to get a little complicated here, but 2a right there, minus 5a right there, and 8 right there. So all those are going to be 2a minus 5a equal to 8. And then there was no x term on the right-hand side, so I could also say that my x term should be equal to 0. And when I start to simplify this, I've got a minus 5a plus 4a. That's 5a minus 5a. X is also times 0 on the left-hand side. And then I've got plus 2a minus 5a, so that's minus 3a, equal to 8 plus x times 0. And so the x's I don't have to worry about. All I have left is minus 3a is equal to 8. 0 equals 0, I guess. But that's just 8 equal to minus 8 over 3. And so my y sub p was equal to ax e to the x is actually just going to be minus 8 over 3 x e to the x. And then the general solution is y equal to c1 y1 plus c2 y2 plus y sub p, or y equal to c1 e to the x plus c2, I think e to the 4x. Yep. Minus 8 over 3x e to the x. And we've solved the problem, and unfortunately ran over again. In the next video, we'll do another example to keep practicing this.